Alright guys, so here's the second video in the installments that we're doing for review. The next question or issue that was brought up to my attention was writing not only electron configurations, but more specifically the noble gas configurations. So what I did is I wrote out the numbering system for all of the orbitals and the filling order for the orbitals. And I'm going to go through that with you just to make sure that you understand, again, why we go from a 3p to a 4s and not from a 3p to a 3d, even though it looks like that's how you should do it on the little diagram. And then I'm going to show you, we'll write the full, and then we'll go to the noble gas, and we'll do one just completely noble gas. All right, so I'm going to do it for nickel. Nickel is number 28 on the periodic table. So again, which means then if you have 28, number 28, that means you have 28 electrons. Okay, or 28 arrows that we're going to account for. So again, if you follow the filling order, you're going to go 1s, and then you're going to go to the 2s. Then you're going to go to a 2p and a 3s. Then you're going to go to a 3p and then the 4s. Notice we're not going sideways, we're going diagonal. So 1s, 2s, 2p, 3s, 3p, 4s. Just like we did down here. 1s2, 2s2, 2p6, 3s2, 3p, 4s, then 3d. Notice 3p, 4s, then 3d, then back up to a 4p. All right, so there's going to be your issue. And just so you know, every time a group comes into the periodic table, like notice you're at the s's here and then you're at the p's over here. So the s's and p's are the same number as the row number. 1s, 2s, 2p, 1s, 2s, 3s, 4s, and so forth. The p's are the same way. So this is my 2p, this is my 3p, 4p, 5p, 6p, and 7p. All of a sudden, as you're doing the electron configurations after 4s, this whole group is the d's. When they come in, it's one less. So these are the 3d's. What a lot of you are forgetting is that these two rows down here fit into the periodic table. Because they fit into the periodic table, if this is row 6, so is this. So that down there is row 6. And if I were you, I would make sure that I maybe even wrote that somewhere so that you know that that's rows 6 and 7 on the periodic table. Okay, so once you get to 6 and 7, and then the F's, which are these down here, these guys are 2 less than the row number. So technically, this is in the 6th row, but this is my 4F, and this is my 5F. We'll get into that later. Don't worry about that for right now. Okay, so back to our electron configuration for nickel. Okay, so for nickel, we're going to start with our 1s like we say. So I'm going to write 1s. And then I know that an S can hold 2. Remember, you should also know that S can hold 2, P can hold a maximum of 6, D a maximum of 10, and F is a maximum of 14 electrons. So now with that being said, a 1s can hold 2. After 1s comes 2s, and an S can hold 2. After 2s comes 2p, and a P can hold 6. Now if I stop there, how do you know how far you've gotten? You'll count up the superscripts. The superscripts are your electrons. So 2 plus 2 plus 6, that's 10 electrons. Again, there's neon. Okay, so at that point, we're not where we need to be. We're only at 10 electrons. We need to go to 28. So we're going to keep going. After 2p comes 3s. And an S again can hold 2. Then after 3s comes 3p, can hold 6. And then after 3p comes 4s. And that's 2. Add all those up, that's 20. You're at calcium again. Okay, keep going. You have to go to 28. Okay, so after a 4s comes 3d. Now here's the next question. How many can a D hold? A D can hold a maximum of 10. If I do 20 here plus another 10, that's going to give me 30 electrons. I don't need 30, I only need 28, which means that this d orbital, I can stop at the 8 and everything will be fine. And if I add all those up, that's equal to 28. So we're good. We are now done with that electron configuration for nickel. Okay, and if you want to use the periodic table to check it, 1s2 starts at the H, so we're at H, 1s2. And then 2s2. Okay, well, keep going. 2s2, 2p6, 3s2, 3p6, 4s2, 3d8. 1, 2, 3, 4, 5, 6, 7, 8. There's nickel. Okay, now if you wanted to shorten this up to do the noble gas configuration, okay, we just did the regular electron configuration. Let's do the noble gas configuration. Okay, so in order to do the noble gas configuration, it's really pretty easy. You're just going to go back and find what the noble gas is before nickel. It's like a game board. What's the noble gas before nickel? Not after it, but before it. What noble gas did I have to go through to get to nickel? The last noble gas is argon. That's 18. So I'm going to put in parentheses or in brackets Ar. Now, as I just said, that accounts for 18 electrons. So I'm going to put 18 right here, just so that I don't forget. That accounts for 18 electrons. If you go through here and you find it, a P6 is always a noble gas. Anything that's a P6 is a noble gas. P6 means it's full. Okay, so a P6 is this column right here. So that means that up to there, that whole thing right there is argon. So I don't have to write any of that. I can just write the rest of this. So I would write here the 4s2 and 3d8 and I'd be done. But now, how do you do that if you don't want to write the whole thing out and you literally want to do a shorthand method? Here's how you do it. Argon is 18. That was our last P6 on here. Okay, we said we were going to stop at argon. Argon is 18. The next one is 19. Well, 19 is potassium, and that's in my 4. These are my S's. So this is the 4th row. This is my 4s. So I'm going to write 4s. And again, how many can an S hold? It can hold 2. So this is 4s2. And then after a 4s comes my 3d. 3d. Now, do again what we just did before. 18 plus 2 is 20. I need 8 more. A D can hold 10 maximum, which means I can put all 8 there. Notice 4s2, 3d8, 4s2, 3d8. Now, you'll see in some places they're going to write the D before the S in your electron configurations. Technically, that's wrong. That's the way I had it accidentally on one of the quizzes, and I'm very, very sorry that I did that, especially since I took off points for some of you who did it in your work. Keep this in mind. The most important thing about all of this is that you follow the filling order, just like the Aufbau principle says. It's in the order of lowest energy, so it should be 4s2, then 3d8. All right, and then again, if you add it all up, 18 plus 2 plus 8, that gives you your 28. You're done. All right, so I'm going to go very, very quickly to uranium because I know I've already bored majority of you to tears. Okay, so here we go. Uranium is number 92. That's a lot of electrons. 92 electrons. No one wants to write out 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and so on. Instead, let's do the shorthand method. So, we're going to find the noble gas before 92. Okay, now here's the tricky part, as if all of this isn't tricky. Okay, the tricky part is this. Uranium is down here at the bottom. He's in your actinide series. He is actually in the 7th row, correct? This fits here, which means he's really in this little area right there. So what happens is this. We're going all the way to the 7s. We have to get all the way down to 7s because this is my 7th row. So if this fits in here, that means I'm looking for the noble gas before the 7th row. Well, what noble gas is before the 7th row? Rn. So we're going to write Rn. Rn is going to go in brackets. Rn. Now, how many electrons is Rn? Rn is 86 electrons. Thank goodness we just accounted for 86 electrons that we didn't have to write. Okay, Rn is 86. Well, what number comes after 86? 87. Francium, a very, very important element on the periodic table. We'll talk about that one later. So if that's 87, we now know that this is our 7, these are our S's, so we're going to start with 7S. So now I write 7S. What's next? Well, like we said before, an S has 2 maximum electrons. So what's 86 plus 2? 88, correct. So after 88, I need to now go to 92. Well, 92 minus 88, very good, is 4. So I need to account for 4 more electrons. Notice if I do this. Okay, after 7S, now comes 5F. 5F. Like I said in the last video, these fit in here and are 2 less than the row number. So this is 4F, this is 5F. So my 5Fs are right here, and I'm going to write my 5F. And we said, how many more do we need? 4, right? We're at 86 plus 2 is 88. We have 92, so 92 minus 88 is 4 electrons. An F can hold 14 electrons, plenty. So 4 is written here, and we should be done. If you add it up, 86, 87, 88, 89, 90, 91, 92 electrons. Check, we are done. And if you want to check the periodic table to make sure that you're right, look at your periodic table. We said that it is in Rn. So if you go to look at Rn, it's 86. After 86 comes the 7s. 7s, and there's 2 of them in there. 7s2, and then 5f14. If you go to the f's, which are here, and they fit in here, 4 in, 1, 2, 3, 4. Sorry, you can't see that. Nice. 1, 2, 3, 4. There's uranium. Done.